In this video, we're going to examine one of my favorite physics problems. The problem is that we throw a ball and we want to know what is the farthest distance that ball can go. The way we are going to approach this problem is by breaking it into two parts. What happens in the y direction and what happens in the x direction. Then we'll use some assumptions to simplify our equations and some trigonometry to solve our equations in the end. To start, we are going to look at our initial problem, which is I throw a ball at some velocity v at some angle theta to the horizon. In kinematics, to solve this problem, we're going to have to break it up into two different problems. One for our x direction and another for our y direction. Using some trig, we can solve for our initial velocities in the x and y direction. We get that our velocity in the x direction is v times the cosine of theta, and our y velocity is v times the sine of theta. Now we can set up our equations that describe the position of our object. I'll start with the more complex of the two, which is our position in the y direction. This can be given as negative 1/2 gt squared plus vy times t. We'll assume that there's no air resistance and that the ball is launched at ground level. This will just help us solve this problem. Air resistance makes physics problems significantly more complex. Since there is no gravity acting on the lateral motion, our x equation is pretty simple. Our position for x is given by vx times t. Now we have a few equations and a few unknowns. We want to know when the ball hits the ground, which means that our y value is equal to 0. So we can conclude that 0 equals negative 1/2 gt squared plus vy times t. Doing some algebra, we can eventually get to that t equals 2 times vy divided by g. We can take this time value and plug it into our x equation to get the distance that the ball travels. This gives that our x distance is equal to v sub x times 2 v sub y divided by g. We know what our v sub x and v sub y are in terms of v naught. V sub x is v naught cosine and v sub y is v naught sine. Substituting those in, we get 2 times v naught cosine theta times v naught sine theta all divided by g. We can use some trigonometry to actually group the 2 cosine theta sine theta together, as this is just sine of 2 theta. Now we have an equation which is v naught squared times sine 2 theta all over g. This is our x distance. We want our x distance to be as large as possible, so we need to find the theta that maximizes sine of 2 theta. Sine of theta is the largest when theta is equal to 90 degrees, so that means that 2 theta is equal to 90, which means that theta is equal to 45. Plugging that in, we get that our max distance is equal to v naught squared times 1 all divided by g. Thus, the farthest we would be able to throw a ball under these conditions is equal to v naught squared all divided by g. I hope you found that interesting. I really like kinematics problems. They tend to be a lot of fun. They can get way more complex once you start adding more variables, but I always thought this one was a pretty cool and fun one. So that's everything. Thanks for watching.